This is question 1 of the chapter on Poisson regression in the Regression Models book. It looks at the seatbelt dataset that we've been analyzing quite a bit. It asks us to fit a Poisson regression GLM with drivers killed as the outcome, kilometers, petrol price, and law as predictors, and to interpret our results. So we've already done some data manipulation, and so let's do fit is GLM of drivers killed. We want petrol price normalized like I did before, and kilometers in 1,000 kilometer centered units, and then plus the law, and we want family equals Poisson up and data equals seatbelts. Okay, and then summary fit coef. Okay, and I like to round it just because it's so many decimal places. I'm looking at it this way, so I like to round it to 3 decimal places. So let's look, for example, at the law variable. So this is negative 0.115. So if we exponentiate that, it's better to exponentiate it. So that, without exponentiating it, is the decrease in the log of the expected numbers of drivers killed, comparing before and after the law having been enacted. And let's 1 minus this. So what we see now is about, so if we exponentiate it, we're saying that there's about an 11% decrease in the expected number of drivers killed for before and after enacting the law. So enacting the law decreased the expected number of drivers killed by 11%. Let's look at MMC. That is the kilometers in 1,000 kilometer units. Okay, so that's also negative. So let's do 1 minus x of that. It should be about a 1% decrease. So it's about 1%. So what this coefficient is saying is that there's about a roughly 1% decrease in the expected number of drivers killed for every 1,000 additional miles of driver distance that month. The intercept is the expected number of drivers killed on the log scale. So if we exp 4.820, we get 123, and that is, according to this model, the expected number of drivers killed for the average number, for the average petrol price, the average number of kilometers driven, because remember I centered those 2 variables, and at the time when the law was not enacted, for when the law variable was 0. Okay, so interpreting your logistic regression coefficients is quite easy. If you don't exponentiate them, they're all interpreted on the log of the expected value of the outcome scale. If you do exponentiate them, it's then on the relative scale for a 1 unit increase in that variable. So for the binary law variable, it's going from 0 to 1. For the kilometers variable, which I converted to 1,000 kilometer units, it's going 1,000 kilometers addition to kilometers driven. For petrol price, because I converted that to standard deviation units, that's 1 standard deviation increase in petrol price. Okay?